CNT125, we're continuing our walk through Chapter 9. We just got done talking access lists, so we're now going to take a look at proxy servers. Proxy servers are just that. They're acting as a proxy, a middleman, a pass-through point from client and, we'll say, internet connection. These work at the application layer of the OSI model, provide a low level of security, but again, they act as that middleman between a client and the internet connection. Some of you might remember maybe back in high school, if you tried to, from your maybe a school computer, tried to get out to a website that wasn't school related, maybe it was just like watching an ESPN basketball game or something, it wouldn't allow you. That's because there was a proxy server sitting in the middle, and it does a little bit of filtering, and as you try to pass through, it's like, nah, I can't let you do that. So it's acting as that middleman. Well, coming back is the helpful part. Coming from the internet back, this sits between the internet and you. So it's a low-level protection, but it's another piece of the protection puzzle, if you will. Some places will use proxy servers to do that. NAT, Layer 3, IP address translation, proxy server layer 7, it's your relay service. And just that, we're saying it's shielding the client from the outside. Shielding it from the outside. There is such a thing as a reverse proxy as well. Provides service to the internet clients from servers on its own network. So it's kind of that pass through, that middleman into the servers that an outside client might actually need. Moving on to firewalls. Firewalls, later, again, a little bit later in the semester, we're going to actually hook up some hardware appliance firewalls, work with some software appliance, or work for some software firewalls. So we'll get a chance to work with some of these in the lab room. But let's get some of the concepts under our belt for now. This is a specialized device selectively filtering and blocking traffic between the network and the outside. Again, another utility, another piece of software or device that's acting as the bouncer at the door, checking IDs and that sort of thing. There is such a thing as a network-based firewall and a host-based firewall. Network-based firewall would be here, protecting the whole network. Host would be over here, protecting an individual host. But let's take a look at them a little bit closer. Your network-based firewall is just that. It's protecting the entire network and usually sits at the edge of the network, protecting all the traffic or watching all the traffic coming and going. Things like a Cisco ASA or a Fortinet FortiGate would be examples of a network-based firewall. This kind of thing like this here. This is actually very similar to the one we'll be using in the lab room. Previously, we used to use these, just kind of giving you a little insight as to some of the equipment. Again, this is sitting here. All the traffic has to flow through it. All the traffic from the internet has to flow through it. So it's designed to try to protect the whole network. Meanwhile, a host-based firewall is usually an application running on a host machine. It's there to just protect that host. Something like Windows Defender Firewall would be an example of that. And I throw a picture in here just to kind of jog your memory if you've ever worked with that. We'll be working with that in the lab room as well. So that is here protecting that host. In real life, you might actually have both. You might have the network-based firewall checking for certain things. You might have a host firewall here checking for certain things, permitting or denying. And as we just got done talking access lists, we might have access lists here and VLANs here. So we might have multiple layers of security. There is such a thing as a packet filtering firewall. That's the simplest type of firewall. A lot of the, homeowner routers, that sort of thing, are a packet filtering firewall. It examines the header of every packet. It looks at the access list for the filtering rules and can block or, permit or deny based on that header. And it might be the IP header, it might be the TCP header that it's looking at, but it's looking at the individual packet, not the stream of traffic, the individual packet. One idea with firewall rules, we have inbound and outbound. Very similar to when we were looking at access lists. They remind us here that, here's our private LAN. Inbound rules would be checked here on the firewall. Outbound rules would be checked here. Okay. And on this side of the firewall, on this interface, inbound's coming from the internet. Outbound's going that way, okay? So you might actually have a set of rules here to deny certain traffic from coming in, and you might have a different set of rules denying certain types of traffic from leaving. So I'll give you the example. We'll block Telnet. We don't want Telnet coming into the network, but we might also be blocking FTP because we don't want data being shipped out of our network as well. You know, maybe secret, or even just customer files, customer data, that sort of thing. We might not want to allow that to leave the network. Firewall default configuration, many times will block common stuff or sometimes everything. Some firewalls will block everything and you have to permit through what you want. Some will block common things and then you continue working on maybe blocking other things or permitting certain things that you want through. And your network administrator is the one that's going to alter that, and we will do that as well. We'll do some filters on our firewall, add some filters and block some traffic and see it happen. This list of criteria should look very similar to when we talked access lists. Source and destination IP, source and destination ports, certain flags on a TCP header, resets and those sorts of things, synchronous acknowledgements, that sort of stuff. Transmission GGDP or ICMP, ping trace. Packet status is the first or subsequent packet. Packet status is inbound to or outbound from the private network. These can all be criteria. So a couple more here that we didn't have before with our access list. Common packet filtering firewall criteria, some examples. Admin can prevent any IP address that does not begin with the beginning of our network from being allowed to access the network's router and services. Maybe that's a specific subnet for admin or a specific subnet for the admin people or users in the network, if you will. Admin could disable or block certain well-known ports, insecure net BIOS ports, etc. If hacker spoofs an IP address to start with blah, it still cannot access the resource via this. So there might be a couple layers here of permitting and denying. Ports can be blocked not only in firewalls, but also on the routers, as we mentioned before, servers, etc. So web servers are designed to listen to port 80. We might block everything else. But we might allow a certain port like 22 SSH into a certain device, into a certain IP or a certain device. And here, we might need to write a special permit rule for SSH to the web server. You might need to spell out that 22 is permitted only to a certain IP or open to a certain subnet. There is next generation firewalls that can be used. Sorry about the pause there. Big sneeze snuck up on me. Next generation firewalls, some of the new firewalls that you run into might see them classified as that, can monitor and limit traffic based on specific applications and adapt to certain applications, users, groups, etc. There's also such the terminology of unified threat management. This is more of a strategy that would combine a number of different things to have your overall security plan. So talking about access lists and VLANs and firewall filters and firewall filter rules and those sorts of things. All that might come under the heading of unified threat management. Optional firewall functions that would need to be considered or could be considered, whether you're dealing with any kind of encryption, VPN kind of thing. I don't know if it mentions it down there. User authentication, centralized management of this, easy rule establishment, logging and auditing, protecting internal LAN's address identity to the outside, like NAT and so forth, monitor packets according to existing traffic streams, application layer filtering, all kinds of other things that might either need to be a consideration or configured as part of a consideration of your plan, your security plan. We can also categorize firewalls another way. We categorized them before as network and host, network-based firewall, host-based firewall. We can also categorize them by stateful or stateless. Stateless is kind of like your packet filtering firewall. It's just looking at every individual packet as it comes in, making a decision, and moving on to the next one. It is faster than stateful, but it's not very sophisticated because I'm just looking at each individual packet and making a decision based on what it sees there. The stateful is looking at like almost a conversation stream. If somebody's downloading a web page or something, it's looking at that whole communication stream and looking at that going, is this belong to an existing stream that we've permitted? Okay, go ahead. So it's a little slower than stateless, but it is more sophisticated because it's like, oh, this is already a stream we've authenticated. It's okay. Let it through. So sometimes when you're looking at firewalls, you'll see them indicated as stateless or stateful. Keep that in the back of your brain. Troubleshooting firewalls. Most common firewall failure or the most common cause of firewall failure is misconfiguration. Whether it be subnet, whether it be port, or, I'll even say TCP UDP. Sometimes you'll configure to block TCP when you really should be blocking UDP, or vice versa. I permitted TCP, but I really need to be permitting UDP. So the other one is getting blocked, if you will. It needs to be strict to block what you want, but not too strict, because I might not let through some other things I need. And any sort of like letting traffic through, the slang name is punching a hole in the firewall. Just keep that in another term in the back of your brain there. Cloud platforms embed some security, but we do also have kind of a responsibility of they have responsibility for some security, and we also have some responsibility as well. Think about back to when we were doing our cloud labs. We had some users and permissions and groups, and we even tested that. So that is part of it, as well as when you create that infrastructure in there with the subnets and all, you might be creating a virtual firewall in there for permitting and denying traffic on there too. So they remind us about this as a shared responsibility model. We're responsible for some, and your cloud provider is responsible for some, for your overall security. Internet connectivity issues. As we go this semester, we have been and we will be doing all kinds of troubleshooting. We even have a troubleshooting chapter that I will deal with a lot of these issues later. But as we go this semester, some things to always be thinking about. If I lose internet connectivity, it could be one of many things. It could actually be an issue with the interface that we're working with, whether it's on our computer or what. DNS issue, maybe it's pointing to the wrong DNS server. Maybe the router we're connected is not configured and passing data correctly, or even if we're dealing with cellular, maybe the roaming is not configured correctly, and there might even be an interface error as far as connecting to. So I break these out for you a little bit. We could have interference from, wireless cause radio frequencies and other things in the air can cause errors with wireless networks. We can also have interference affect wired connections too. Any kind of intermittent connections might be the cause of some interference. DNS, if we're pointing the wrong DNS server, it's not going to resolve things for us. Or if I point to a DNS server that doesn't exist, it's not going to resolve things for us. So a lot of times if you're trying to browse it and you're not getting anywhere, it might be just a DNS issue. I don't have the DNS address plugged in, or it might be pointing the wrong direction. Router misconfigured, as we mentioned. We could be having wrong subnets or wrong routing tables. I might need to go through and look at the routing table, and then I might need to go look at the router and look at specific interface addresses and maybe even the routing protocol config. As we do our routing protocol config in this lab, those would be some things we're paying attention to. Interface error, as we said, we might be connected to something that is not recognizing what we're connecting to, so it shuts down. We might not have enabled the port correctly or configured the port correctly, so it wants to shut down. Those are all things we would be checking. And then we said here about roaming. If you're dealing with any kind of cellular, it might not be handing off to the next site correctly. We have used this, and we will continue to use this, the show run command, looking at our running config, looking through the interfaces and IP addresses and subnet masks, and we're looking at every single digit now. Having one number off could be pointing to the wrong network and or something that doesn't exist. So we need to be looking at all of our IP addressing and subnet masks, make sure they're correct. And I might even be looking at show interface to make sure the interface itself is on and configured. Those are some things we check. And later on, when we do some port security, we'd want to make sure the port is not shut down because of a security violation. Here's looking at a show interfaces. And then a show IP route. I'd be looking at a routing table. We'll be doing that a bunch in the routing protocol lab with this chapter. Looking at show IP route and go, are all the networks or subnets that we need on there? If they are, then we should be routing to it. If a subnet or a network is not on there, there's no way we can route to it. So we might need to alter or update our routing protocol configuration so the routing table is updated with the correct networks. So there's a couple tips on some troubleshooting. We'll be doing some of those in the lab as we go this semester. And that should wrap up Chapter 9 for us.